liner leaves a port at P. Okay, so liner starts here. Goes 15 kilometers on a course of 37 degrees. What they're talking about here, excuse me, is that sailors and pilots use compass headings to show their directions. It's not the same as what mathematicians use. They say north is 0, 0, 0. They call east 0, 9, or 0. South is 1, 8, 0. West is 2, 7, 0. They come all the way around to 3, 5, 9, and then 1 degree to the right of that is back to north. So this course of 37 degrees means due north is like that, and there's 37 degrees here. I don't know if that's going to be a big deal in this question yet, but that should be what this 37 is about. They say it was a 15-kilometer trip here, so that distance is 15. They get to Q, then they go to 270, so they're headed west now, and they go another 12 clicks that way. Complete the sketch to illustrate this information. Done. They already had the sketch, I just had to put in some labeling. And calculate the distance and course the liner must sail on to return from R to P. So here, if the boat wants to get back home, it's going to have to make a turn and sail back. How do we do this? We need some more angles, basically. We don't have a single good angle. This 37 isn't everything that happens at the corner P. So let's see what else we can figure out here. If we extend this north line like so, it cuts this triangle in two, and the good thing is, because this is due west and this line is due north, they cross at 90 degrees, which means, yay, right triangles. That's helpful. Always glad to see those. The other thing it does for us is, if you look at this right-hand triangle, it contains a 90-degree angle, a 37-degree angle, which isn't doing us much good right now, and angle Q. How big is angle Q? There's 180 degrees in this triangle. 90 of them have been used up here, so we have 90 left. We use up 37 of them here, so there must be 53 degrees left. That's better. Now we have an authentic angle that we can use. Now that we have that, could we find this side? I'll call it lowercase q. Or I'll rephrase that. We can find side Q. How do we do it? If you think about the sine law requires that we have a side, 12, and the opposite angle. Well, we don't have a complete angle here. We have 15, but we don't have the opposite angle. We have Q and rats. We don't have enough to set up the sine law. But we do have the cosine law. We can use the cosine law here, and it's going to come out like this. I'll just get these labeled. Angle P and side P is across from it. This is angle R, so side R is across from it. You can write the cosine law as follows. Q squared equals P squared plus R squared minus 2PR cosine Q. Right? Remember the structure of this, where it has the center line values at the beginning and end, and then the off to the side values, each occurring twice together. We can use that to find our Q. So Q squared is 12 squared. Actually, I'll write that out. 12 squared plus 15 squared minus 2 times 12 times 15 cosine, and the angle across from the Q is 53 degrees. Q squared is 144. 15 squared is 225 minus calculator time. 2 times 12 times 15 times the cosine of 53 is 216.7. So Q squared is 144 plus 225 minus 216.7. is 152.3, and don't forget the square root. It's kind of important. Q, that distance is 12.3 kilometers. Good, we have a distance. So calculate the distance, got it. Now we need an angle. How do we get an angle out of this? Well, we could find this angle now because we've got opposite pairs now. Thanks to the side that we just worked out, let's make a list of what we've got. We have this 12.3 kilometer side, and we have the angle that's across from it. And then we have the angle we're trying to find, angle R, and across from it we have 15 kilometers. So, brilliant. We know enough to actually solve this thing. Using the sine law, I'll put it over here so it's close to the diagram. You can say sine R over 15 equals sine 53 over 12.3. Cross multiply. 15 times the sine of 53 divided by 12.3, arcsine 77 degrees. R is 77. So that's the angle. Now let's see how we're going to use it. If you're right there and you're the navigator on this ship getting ready to make this turn, here's your compass that says north, east, south, west. This angle is 77. That means if this is 0 degrees, east is 90 degrees, we need another 77 degrees on top of that. So the course we need to steer is 90 degrees, that's east, plus another 77. We need course 167, like this direction. Our ship needs to go southeast, which agrees with our diagram. So, final answer, the ship has to go 12.3 kilometers on a course of 167 degrees.